In an alternating current circuit with a purely resistive load, current and voltage are in phase because the current is directly proportional to the applied voltage, according to the Ohm's law. There are no reactive components, such as inductors or capacitors, that introduce phase shifts between voltage and current, so both quantities oscillate simultaneously, reaching their positive and negative peaks at the same time. With the purely resistive load, the power factor is equal to 1, since the phase angle between voltage and current is 0 degrees. When a circuit contains reactive elements, current and voltage become out of phase. This makes it harder to measure the power dissipated by the load and, more importantly, leads to higher energy consumption at the expense of power system efficiency. We will now perform some current measurements of a hairdryer to determine its power dissipation. Although this is a relatively small device, it draws a significant amount of current as confirmed by its nameplate data. The hairdryer will be set to its maximum power. It consists of a resistive heating element which consumes active power and an inductive component, the motor, which generates reactive power. The generic electrical diagram shows all of its main components. Invasive methods require interrupting the circuit to insert a measuring instrument. In these cases, strict safety precautions must be followed, as even a minor mistake can cause a short circuit or other accidental damage. The first method examined involves inserting an analog or digital ammeter directly in series with the load, becoming an integral part of the circuit. It therefore measures the current flowing through the line. As mentioned earlier, invasive methods are generally more accurate but require breaking the circuit, which can be dangerous if proper precautions are not taken, especially at 230 volts. Another excellent method for measuring current is using a shunt resistor along with a voltmeter. A precision shunt resistor is inserted in series with the load, and the voltage drop across it is measured with a voltmeter. The current is then calculated using Ohm's law. The shunt resistor used, homemade, has a very low value of only 0.057 ohms. A shunt must always have an extremely low resistance to prevent excessive heating. As shown in the images, a voltage of 0.473 volts develops across it during operation, and using Ohm's law, the current flowing through the circuit is easily calculated to be about 8.3 amps, which is very close to the previous measurement with the ammeter. The next method uses a Hall effect current sensor. It is powered with 5 volts. The model used can measure up to 30 amperes of current with an analog output of 66 millivolts per ampere. If no current is flowing, the output voltage is VCC divided by 2. With this wiring, we can measure the current passing through the line. The sensor is inserted in series with the load and provides a proportional signal that can be read by an external instrument, voltmeter, or a microcontroller's ADC. From the measured voltage, the no load voltage, 2.5 volts, is subtracted and the result is divided by 0.066. The current is about 8.33 amperes. Non-invasive methods do not require breaking the circuit and are safer for high voltage measurements, even though they may be less precise. Very simple way to measure the current and power of a load is by using an energy meter, which is readily available at low cost. It is connected in series before the load and measures the active power consumed by the hair dryer along with the current. Some models provide accurate values by taking the power factor into account. We connect the device as shown in the previous diagram and turn on the load. We select the parameter to be measured using the buttons, and the current value is immediately shown in real time on the display. As seen, the current flowing through the circuit is about 8.2 amps. This is the last method examined, but in reality many others exist. It involves using a clamp meter, which inductively measures current through the magnetic field generated by the conductor. The operation is very simple. The clamp has a dial to select the type of measurement and the appropriate range. The correct range must be selected based on the requirements. At this point, only one wire, either phase or neutral, not both, must pass through the clamp ring. The load can then be started and the current value can be read on the display. The current measured is about 8.3 amperes. It is now interesting to review all the measurements taken. As can be seen, although they vary slightly, their overall values are equivalent. It is fairly easy to calculate the power dissipated by the load by multiplying the average current by the supply voltage. Thanks for watching, and see you in the next episode of PowerUp CircuitLab.